Assalamualaikum, my name is Muhammad Rodi bin Zefri and my matrix number is 08 DKA21F2074.
Assalamualaikum and hi, my name is Muhammad Ismail Hazib bin Hamidi. My matrix number is 08 DKA21F2064.
Hi, my name is Sharifah Nabaiti binti Said Amazon and my matrix number is 08DKA21F2003.
Hi, my name is Tiro Umaira binti Warafi and my matrix number is 08DKA21F2056. And here our group will present the topic of trigonometry in architecture.
What is trigonometry? Trigonometry is the branch of mathematics concerned with specific function of angles and their application to calculation. Trigonometry helps us a lot to find angles and distance, and trigonometry are widely used in science, architecture, engineering, mapmaking, and many more examples. There are 6 functions of an angle commonly used in trigonometry. Their names and abbreviation are sin, cosine, tangent, cotangent, secant, on secant. Okay, next, how to apply trigonometry in our daily life. One of the examples to apply trigonometry is in the field of architect. An architect must master and be proficient with the topic of trigonometry in order to become a professional architect. By applying the principle of mathematics and design, most architects were able to build pyramids and other structures that exist today. Since angles are the complicated part to find, then the sins, cosines, and tangent are some of the trigonometry functions used by ancient and modern architects in construction their work.
Height and distance, most significant definition that I use when dealing with height and distance. Line of sight. It is the line drawn from the eyes of an observer to the point in the object viewed by observer. For example, here the cat is observer and the object is the bird. Let's learn more about two angles in trigonometry. For the first one, the angle of trapezium. The angle between horizontal and the line of sight joining an observation point to an object below the horizontal level. For the second one, the angle of elevation. The angle between horizontal and the line of sight joining an observation point to an elevated object.
I will explain more about trigonometry in architecture. Trigonometry not only help with calculation of height, roof slope, ground surface, and line angle, but it also help compute precision, loads, and force. Recall that architecture are not only responsible for designer mathematical representation of designer plan, but they also have to ensure that a building is functioning and safe. Further, sine and cosine function in trigonometry help architect to understand and calculate force and loads. In addition to building safety, architects are also responsible for calculating the budget to be used for the construction of the building. With the help of trigonometry, architects determine the budget plan for the project whole construction. Architects use trigonometry to make sure that their building doesn't collapse. The angle of trusses which provide support for the roof and the length of the rafter are decided using trigonometry. If you have triangular roof and the length of the rafter and the length of the roof horizontally is known, you can apply the constant function to calculate the angle at which the trusses should be cut for the maximum amount of support.
So this is the example of the question. The question is, given the information below, find the height of the cliff. So the height of the cliff is AB. So first thing first, we need to find the angle of B. So we know, right, the angle of one triangle is 180, right? So CBD equal to 180 minus 38 minus 59. So we get 83 degrees. So here B is 83 degree. So then we need to find the length of CB. So using the formula, sine 59 over CB equal to sine 83 over 226. So here sine 59 times 226 equal sine 83 times CB. So here we get sine 59 times 226, we get 193.7 equal to sine 83 times CB. So we need to find CB, right? So CB equal to 193.7 over sine 83. So here we get the length of CB is 195.15 meter. So here the length of CB is 165.15 meter. So the question is we need to find the height of the cliff. So the height of the cliff is AB. So A, B, C. Here is 41 degrees. CB 165.15. So we know that this is hypotenuse, this is opposite, and this is adjacent. So here we have info of the adjacent and also the angle of C, right? So I think we need to find AB. So you can use tangent equal opposite over adjacent. So here tangent 41 degree equal to opposite over 165.15. So we need to find opposite. So tangent 41 times 195.15. So we will get 169.68 meter, right? So sorry. So the height of the cliff is, so we get, here is the 41, here is 195.15 meter, and here is the height of the cliff is 169.68 meter. So we get the answer.
So, we have learned architect and engineer are work together because the responsibilities of an engineer and architect are often overlap. Both professions are integral to the design and construction of structures, such as building and bridges. One way that engineer and architect communicate their ideas to each other is through blueprint or technical drawing. So, we realized that trigonometry can be used in many areas such as astronomy and architecture that can aid in calculating many things. It helps in real-life application and not only in our test and exam. We can conclude that without trigonometry, life will be difficult. Thank you.